sort of dip our toes into the world of combinatorics. Let's start with a permutation question. How many different 4-digit pins can be formed using the digits 0 to 9 if no digit can be repeated? So you have a 4-digit keypad and the digits 0 to 9, so 0 is a valid number. And so you'd put in 1 digit, 8, 0, 1, 2. This would be a valid pin because no digits are repeating and all the digits are formed from digits from 0 to 9, right? But how many different pins can you make with these numbers? You're not gonna count out every pin, are you? Like, here we could switch up the 0 and the 8. That's a different pin. We could put the 8 on the other side. This would be a different pin. You go through the process for each number, for each spot, you'll never get it done. Now, intuitively, another way we can think about this problem is, okay, we have our 4 different pin entries, and we have 10 digits total, right? So how many different combinations can we have in this one slot? Well, we can have 10 because there are 10 different digits. Since none can repeat, well, how many can go in the next? Well, there are 9 different ones we can use because we already used one, so 9. And we already used 2 now, so there's 8 left, and then 7. And if we take the product of all this, this will give us the number of different 4-digit pin codes that can be made, which if I quickly calculate this is 5,040 different pins. Now, what makes this a permutation question is because the order matters. That is the key difference between permutations and combinations. So when you think permutations, order matters. Because think about it. If you have a pin, and let's say the correct combination was 1, 2, 3, 4, right? You'd be surprised how many people's pins are just that. Well, if you enter the combination 4, 3, 2, 1, will that work? No, because your phone is set to only recognize this in this order, right? Order matters. And so these 5,040 different pins are for different orders of things, different pins you can make. And now we figured this question out pretty intuitively, but there's also a more mathematic way of approaching this, which you've probably seen before. It's with the permutation formula of n factorial for n minus r factorial. Now, what the hell does this mean? If you aren't familiar with the factorial notation, this little exclamation mark, it essentially means the product of all numbers from 1 until that number. So for example, 5 factorial would be, you start from 5, and you take the product of all the numbers until 1, which would, I think, make 121, or 120. And so n minus r would, let's say, 5 minus 1, let's say r is 1, well, that would be 4 factorial. So it would just be this part, which would equal equal to, I believe, 24. I don't know why that took me so long. But now, okay, we have a formula for it, but now how do we use it? What is N, what is R? Just to sort of write out a good intuition on what it is. I'll actually type it because it's faster. The permutation formula counts the number of ordered selections of our distinct elements from N. Now that is a bunch of math mumbo jumbo, but what does it mean? Well, you don't really need to know the intricacies of ordered selections and distinct elements just yet. Just understand that our distinct elements is our R, and we're choosing from N. Just recognize these two variables. So ordered selections means how many different slots we're trying to fit our elements into. So in this case, our R is 4 from N from our 10 digits, right? So we have our distinct elements, four different things we're trying to fit things into out of our 10 digits. And we can put this into our permutation formula to get 10 factorial over 10 minus 4 factorial, which is 10 factorial on 6 factorial, which if you put this into a calculator also gives us 5,040, which is exactly what we got by manually doing this process and intuitively thinking about it. And another way of sort of visualizing factorials is, well, what we got here is exactly the same thing here. And let me explain. What is 10 factorial? It's 10 times 9 times 8 times 7 and so on and so forth until 1. What is 6 factorial? 6 times 5 times 4 times 3 times 2 times 1. And now if you know anything about algebra, you can cancel out common factors on the numerator and denominator. So this cancels out our 2 and our 2, our 3 and our 3, all the way until we're left with 10 times 9 times 8 times 7, which is exactly what we had before. So that finds our number of permutations. Just to sort of give another example on how we can use our permutation formula and intuition to find possible ordered manners to do things, right? Our number of permutations. I already have a question in the clipboard if it saved. No. Okay, so I found a question. Suppose you have four books labeled A, B, C, and D. I guess they don't have titles. You want to arrange these three books on a shelf. How many different ways can you do this? Well, just sort of looking at the question, we have four books and three ways to arrange them, or three slots we want to fit them into. So as we saw before, then our N is our 4 and R is 3. Because we're fitting into three slots, distinct selections. We want three elements, and we have four elements to fit into that shelf. Three spots. So figuring this out, let's just rewrite the formula. So n factorial over n minus r factorial becomes putting in our variables, 4 factorial over 4 minus 3 factorial, which is just 4 factorial over 1, so 4 factorial, which is 24 as we found before. So there's 24 different ways to arrange three books. The three books on shelf. Now this is a very basic overview of permutations just to gain some intuition, but just understand that you shouldn't always rely on this formula. It is just to sort of think about dealing with elements and fitting them into slots and dealing with distinct elements and just really getting some intuition about the question you're reading too. So the key takeaways is the permutation formula, finding your variables, and that order matters for permutations. So given our example with the books, say you put, well, we only have three slots. Say you put book A first and then B and C. Well, that's not the same thing as saying you put A first and then C and B. Visually on a shelf, these are two different arrangements, two different looks. It would make no sense to say that they are one permutation, so order matters.